Hello guys, hope you're doing well. In today's video, we will explore the engineering rocket features of SpaceX Starship. But first, don't forget to subscribe to the channel for future videos. This video focuses on the Raptor engine, a next-generation liquid rocket engine built by SpaceX to power company rockets. SpaceX's crazy Raptor engines power the star Musk. I know you might be thinking of what makes them so beautiful, and why are they called the king of rocket engines? This is a bit of a test of SpaceX's Raptor's crazy engine engineering. A Starship is nothing but Raptor engines. They produce power that help the Starship to gain the escape velocity, which is 11.2 kilometers per second. They generate energy to help the Starship escape the gravitational pull of Earth and propel it forward in its orbit. The momentum they produce should be huge, as the Starship is intended to lift heavy loads of up to 100 tons. This is important if Musk's dream of investing in Mars is to make all the necessities of life available to the Earth. SpaceX is not short on powerful rockets. Part of its list of renewable Falcon 9 spacecraft is partially capable of exploding payloads of up to 22,800 kilograms to orbit the ground. The Falcon 9 is powered by a Merlin engine built in-house by SpaceX. However, the star needed something powerful, and SpaceX decided to build a new engine to name it Raptor. SpaceX introduced many crazy ideas that a few rocket companies have tried, and the result has become a beast that makes itself a rocket engine. Each Raptor engine weighs 1.5 tons and will power up to 11 million horsepower. It is the equivalent of 4 Hoover dams. By comparison, the Bugatti Veyron, one of the most powerful sports cars ever made, with a 1/3 engine, but cannot produce more than 1,200 horses. The exhaust engine of the Raptor emits more than 10 times the sound speed. If that doesn't make sense to you, fuel in the room burns at a temperature high enough to melt the walls of a room. If you wonder why the wall does not melt, it is because of the clever way the flame is blocked away from the walls by controlling the flow of gas. Cold fuel is also pumped to the walls as additional protection. The Raptor engine works like a lot of rockets that emit gases fast enough to push the spacecraft forward. However, more sophisticated engineering makes the Raptor a powerful rocket. Engines range from their construction to the average cost of rockets, as SpaceX has chosen a full-phase fire cycle inside the engine. The ignition is handled by a dual redundant spark plug, a flashlight illuminated, which means that there is no need for a special usable igniter liquid, as it is available from Merlin. The Raptor incorporates methane and oxygen cooled deep into the propellants near its cooling point at such low temperatures. The propellant is compact, which increases the overall engine performance. Methane is a better fuel because of its higher performance and lower cost than paraffin or hydrogen-based propellants. It is much easier to store than hydrogen, as it requires less effort to keep it cool at cryogenic levels. It also weighs less than the hydrogen, which means more methane can be stored in the same tank. Methane is better than paraffin, and it latter builds up residues during combustion called coking, which limits the reuse of rockets. Higher efficiency means that a size similar to the Merlin engine, the Raptor engine produces much higher pressure and push. No other rocket engine exists that can produce as much energy using liquid methane and oxygen as a propellant. The development of the Raptor engine is incredibly impressive, especially when you consider that CEO Elon Musk did not learn anything about rocket science in school, but taught himself everything by listening to experts. The choice of engine fuel is another proof of forward thinking. With a team of designers in SpaceX, the star is heading towards Mars. And guess what gas is flowing there? Methane. So the idea is to mine methane in the world. Therefore, the Starship can refuel before taking a return trip. This will make many things easier and make the trip cheaper in bulk. It will be like landing your plane at an outdoor airport and refueling. A fuel stage burning cycle means both oxygen and methane will be completely mixed into the gas phase before entering the combustible chamber. In this way, every drop of fuel is used efficiently. The full flow design makes a lot of sense for a few reasons. For example, eliminating the need for clogging between fuel and oxidizer. This roof is often the source of failure in traditional rockets. Using a full flow design means that the pump system does not need to handle high pressure, which is another potential source of a catastrophic failure. In addition, SpaceX can apply pressure to fire chamber to get more performance. In fact, during testing, the Raptor reached the 330 pressure bar without explosion, setting a performance engine record that would be used for orbital charges. The previous record holder was the Russian RD-180, which was able to withstand 31 pressures. All of this contributes to the high efficiency of the Raptor engines. It is suitable for 1,000 aircraft, which is a major factor in space travel. Compared to rockets from other companies, the Raptor engine is miles ahead. Crush other rockets for efficiency and safety. SpaceX was originally printing 3D elements in the engine that included turbopumps and injections, allowing them to improve development and testing at a fast clip. There are two types of Raptor engines. The sea-level variation will empower the lower star class and is ready to operate on Earth. Another alternative, the vacuum version, will keep the upper stage moving after disconnection from the booster for improvement. By working in space, the vacuum version has a nozzle skirt extension that makes it larger. The difference can easily be seen when both are set aside. In other details and sections, the two types are the same. The most efficient Raptors are not cheap at all. Initially, each engine cost SpaceX $1 million to build, but SpaceX is working to reduce it to $250,000. Cost is important for Musk as he tries to make interplanetary travel accessible to everyone. That is why the Raptor engine is designed to require as little adjustment as possible for maximum use. His company is working to increase production and can make rocket engines in bulk. The immediate goal is to make 500 of them a year. However, if Musk plans to have a 1,000 Starship that makes thousands of flights possible, that volume would need to be significantly increased. One star can use up to 41 Raptor engines. The lower stage may require 31 sea-level variants. Although the actual number has varied during the star test, the upper stage will take 6 Raptors, a combination of both sea-level and vacuum variety. Marine engines are needed to reach Earth and Mars. While SpaceX is in a hurry to eliminate Raptor engines, many people are monitoring NASA's progress. For example, they have touched a star to help place its astronauts on the moon as it revives its space exploration program with the Artemis project. It operates by the 2024 deadline, but beyond this month, the Raptor engine is extremely important to NASA as it hopes to use the star to find astronauts on Mars. In time, travel to distant planets like Jupiter is also on the cards. That is why it has agreed to provide SpaceX with $2.9 billion to support spacecraft development. Another big name waiting for a US military Raptor engine, after hearing the beauty of SpaceX rockets launched its national defense satellites. They plan to use the star for the immediate delivery of goods and services to places on Earth. With powerful Raptor rocket engines, SpaceX builds a flexible engine that produces an unpredictable amount of speed and will empower future spacecraft. On the 5th of September, SpaceX shared a photograph on Twitter showcasing the gigantic Raptor vacuum engine. Elon Musk gave a 50% chance of survival for its initial version. In this first test, he also stated that the thrust is only slightly higher with the big bell nozzle version and the larger bells primarily for efficiency in a vacuum. The Raptor vacuum engine aims for a specific impulse of around 380 seconds, while the initial design is projecting for a specific impulse of 372 seconds. Within less than 3 weeks after shipping to the Texas Rocket Development Facility on the 24th of September 2020, the Raptor vacuum engine completed a full duration test fire at SpaceX. Raptor engine developments are still in progress, and we can expect further details in the next SpaceX Starship event, currently expected in October 2020. We will be covering the major announcements from that event in our future video, so do not forget to subscribe to this channel to know more about SpaceX and Starship developments, and as always, thank you for watching.